Hello, welcome to another video. Apologies for the delay since the last one. I've been feeling a bit run down. So this video we're continuing off on my series of the Odin's interpreter for the Z machine, which I started a month or so ago, 2 months ago maybe. So where we had been at was kind of just getting the Zork game working and various bugs fixed in that. Um, I've actually got to the point where if we look at what we can do, we can actually run quite a lot. If we run something like this in ROM Zebra.com and Zork 1 and give it input, say river. Like here's an example of what it might do. So we're going up into the didn't I? Cool. Went up into the attic, got a rope, and then killed the troll. Went down a thing so we can get the scepter. Then we go and get the boat. Then we blow it up. Then we take the scepter. Then we go to the falls. And we make the rainbow appear, and just for fun, we make the rainbow disappear while we're on it. But as you can see there, nothing actually died. Uh, so it got to the IO error at the end, which is just what happens when it runs out of input like that. It's another thing I kind of want to work on the rehaul of the input output system, which will help with getting now what is it? It will help with getting the input output support better for later versions. Um, I also talked about some. Actually, I'm not sure if I did. There's like some testing ROMs that you can do. I might do some bumping up, and so there's some testing ROMs that you can use. And if we have a look at some of them, we can run them, and it will give some debug options, but that's all right. But yeah, here we can kind of see what the difference between different things. What one was this? Etude. So, you can see one output. One issue is we have to do it like that. One issue is it actually prints more than it can display, whereas most interpreters, Z machine interpreters, they will actually pause and say more, and that is because you only have one screen, and the requirement to do the kind of paging is up to the interpreter. So that's one thing. But yeah, if we kind of like look at things, we can see what I say is right. So to do this, I got some header flags, but this will actually fail when we do that because we don't have any output of colored displays and stuff. So that's kind of another aspect of where I can go. I don't think I want to do that, but out of interest, I made a kind of tester script that will tell me which opcodes are not yet implemented. And we can see with these, there are actually quite a few, which some of them will require. Um, that overhaul of the input output, which this read char will do. And some of them require a bit more things, like try catch will have some kind of mechanism. Um, but interestingly, if we do that same thing, we can see what we haven't done in Zork. And there's only two opcodes. So we've actually kind of finished the game. It should theoretically be not that one, that one. It should theoretically be finishable, but there is one issue where you can't actually save and reload the game. So um, uh, not from. So say for example, we go restore here. I've already saved this file here, and we can see now we are actually up a tree, and we've got some points. So we've got some inventory, and we're in a certain place. So that's some frogs, and what I kind of want to do in this episode is get maybe at least restoring working. Um, if we kind of look at what does it look like? Uh, that will do it. Maybe do that in a like that. So this is actually the entirety of the save file, being Zork 1 dot QTZ, and the QTZ is actually named after this Quetzal, or Quetzal, which is a standard for save files. It unfortunately doesn't have like a nice kind of like it's not included in this annotated version, so we actually have to read it from this lovely interface here. I'll open up just a new page so we can start from the start. So this is kind of what the standard is, and it's I don't know, it's just kind of very to the point, and the ordering is, gosh, uh, not in a kind of normal order. Um, gosh. Right, so kind of what this is saying is it hints at things. So this is going to be IFF type. Doesn't actually say what IFF is. You probably know if you're like in the you were doing stuff at the thing, but if you go to section 8, you can see stuff with IFF. That's a broken link, but you can actually look on Wikipedia, and IFF is called the interchange file format, and it's kind of it's similar to JPEG in a way. Like it kind of reminded me of that momentarily. Why I say that is the first four. What I might do is just for handiness. Um, so the first 4 bytes here, they are actually an ASCII thing saying form, which if we look at the IFF standard, basically there's some group chunks. Basically every chunk is a ID, then a length. And there's some predefined form, list, and cat. Um, and the top level only contains one of, and form is the most common. And I believe, well, yeah, back in like uh, section 2, it says it is a form type. So I guess in the purpose of restoring, which I'll do restoring first because I have an interpreter that can create a save file like this, and once I get restored, then I can work on the save, and then ideally you can go back and forth. But here we can see that form is the first type, and it will have what um, it will have 4 bytes of um, length, and this 190, you'll see that the entire file is a bit over 190. It's 198, which accounts for the first 8 bytes describing the type and the length. So the whole file is essentially that type form plus the length plus those 8 bytes describing those. The interesting part comes in the next thing, where we have the. I don't know why that. Um, uh, when we get the next 4 bytes, which is um, IFZS, which it doesn't actually say what this is meant to stand for. Yeah, I don't think this is actually like it might be interchange file Zork standard or something like that. But I don't know, it doesn't really say it. And so this is kind of an additional form type. So it's basically a group of something. So each form has a bunch of records, which we can see here. So we have that, and then immediate. Yeah. So the form is special that it has a subtype, um, which is what we're looking at. Um, yeah, so basically, once you're in that form, you immediately start into one of the new chunks. And we can see here the first chunk is IFH which is described in 5.4. So we can look at 5.4, which this is kind of saying this is some bytes from the header, and we can have a look and see what it is. I might just bring that there and start using the keyboard a bit more. So here we can see the length of this chunk is, it should be 13, and what D is ABCD. Um, so that is 14, I believe, which it does say that it will be padded out. Which, yeah, it's kind of weird. Um, right, so then it'll go and say the release number. And I guess here is a good point to just kind of have a look here. Um, so the first four, and then the 0058 was the release number, which is essentially this 88. Um, yeah, 58 and 88. 58 in hex and 88 in decimal is the right thing. And then the next 6 bytes are the serial number, and we can see that there 842 blah blah blah. So that happens there, and that's like this 38 to 36. The next one is the checksum, which we don't have here, but we can no, yeah, info dump and ROMs info comms or one dot that. The checksum A129, we can see that there, and 006E. Um, yeah, so the 006E and 6A should be the program counter. Now, the program counter is actually the way we parse instructions are not quite right. So on the restore, we'll have to do something, and on the save, we'll have to do something just to show that it is the right thing, which kind of it's all right. But basically, it, on different versions, the program pointer points to different things. So in version 3 and below, it's a branch instruction, so this will point to where the branch instruction is, whereas currently we parse the entire instruction, and we kind of ignore the fact that the branch could have 1 or 2 bytes in the executor, because that shouldn't really be necessary knowledge, but because of that, we'll have to read the byte before where we are, determine whether it's a 1 or 2 byte branch, and then read the say it's the next byte before, if so. And then version 4 and above, which I guess if we open up this and yeah, so 4 and above, it's a store instruction. So this is going to point just to the single byte for the store, which is easy because we have the program counter after the store. We can just subtract 1 and we're at the store. So that's easy. And that is our first. I'll get back into Vim just so I remember that I'm there. So that is our first header. If we go to here, so this should be, yeah, it gets padded with a 0 byte. Mention that somewhere in there. And then here we have a CMEM, and this is kind of it's in 3.7. It's weird how these are not in order that you would come across them. Like the IF header has to be first. They even say they even say it somewhere here. I'm sure of it. Yeah, the chunk must come before the mem and stacks chunks. So I don't know why that is in a later section. But anyway, the CMEM. So the CMEM is this chunk ID and then the chunk length. So here we have the chunk length is 1180, and it is basically the rest of the memory, rest of the file there. There's also a UMEM, which is a bit easier. So the UMEM is basically machine memory. Here you are. Here's the new machine memory. You do have to restore a couple of bytes. They don't describe it here. They don't describe it here at all, but they probably describe it here. Mm, I thought it did somewhere. Maybe you don't have to. Anyhow, so this memory, basically the gist is because I haven't made many moves, my memory hasn't actually changed much since the uh, from the original file. So how you uh, get the compressed memory is you just do a XOR against it, exclusive OR, um, and then you should either be left with a bunch of zeros or zero meaning no change, and some other byte, which will be the byte that it should be. So if we do this, we should have a bunch of zeros in a row, which is kind of what happens. It, it's just what happens. So here we say we do a run length scheme. So basically, if there's a single zero byte, it actually takes up 2 bytes. So you have to have a zero, then a zero, which I believe it actually starts off with. Yeah, that's the length. So this zero and zero, these 2 0 bytes are actually just 1 0 byte in the output, and then this 2 0 is just a 2 0, and then this 0 to F is actually like 3 0 zeros, basically n plus 1 0 bytes. So that is basically that, and then if the decoded data is shorter than the length of dynamic memory. So yeah, I guess from here, enough rambling on. Um, I think it is probably about right to do we have this? We can add a restore, and what will it need to take? We can bring that back over there. Yeah, so restore is like uh, probably like here. Restore. Um, right. Do we need a branch? We do sometimes need a branch. Case. Right. So if we are less than 3, we will return true. True, else do return false. So that's if we need a branch. What if we need a store? So this will be similar. Right, there's just a um equal to oh, not 7, do that. Um, do that, and z string we never need. Um, um, what are we doing here? Ah, this is actual execution. Um, typo made it a bit hard. Um, we don't have a header. We'll get a header. Um, um, we do that. Um, cool. Except that ran the wrong file. Do that, and now we should get unimplemented. Cool. So we got the boiler print in. So I think for this, this probably needs we'll call it Quetzal.odin. Package Odins. And we'll probably have a Quetzal restore. And this can be a proc. And so the restore can take a bunch of stuff. And it's like never used. Oh yeah, there's where I was looking for the transcription and fix font bit survive. Cool. Um, so in here we will probably just do kit little restore. And maybe have that return a boolean. Maybe do something like this. because if it's successful, it, it shouldn't kind of get to that point. Though, no, we just want this to do something like that. Unsuccessful restore. Cool. Um, so if we go to here, this needs to return a now, and if false, do return false. Would that do the thing? Why do you keep on? Do that. Cool. So now, how do we go about this? So there's like a couple of issues. The actual opcode doesn't actually give any way of uh, seeing where you actually want to restore from. And say if we did restore here, that enter file name and default as Zork actually comes from the interpreter asking. And yeah, so I guess we need some way to get the file name, which here it has a default of zork1.quetzal. So what I might do is, or what could I do? So machine has a ROM file, I believe it is. Yeah, the only match. Um, so we could probably do that, except I don't want to do that. I just want to do that maybe. You've gone back to that. Oh, no, actually, I don't know. Yeah, I don't know. Right, so now it should say which ROM file it's loading from, and we can do some stuff in this. If we look at maybe strings, yeah, strings is the one. So we have a string, and what I want to do is basically get the like it's really a path. I want to does this have a path? And then we can just get a it's got file path. Um yeah, this is exactly what we want. Yeah. So here we can import, yeah, I think it's import and path slash file path um do that. And what was it? Base. Odin run source. Do something like that. Wait, it doesn't exist. It's core file. Yeah, that is the syntax we want. Just the one. How do we do? So yeah, that's how we do it. That makes the file and then that inputs it. Cool. Right, so now it's got just that. So from that, we could probably just do that. And we probably want to like add something to that. Can we get rid of the extension? This is what we're on short stem. Um, Short stem of that thing. So do I need to do that? I think it makes it a bit clearer. Um, cool. So now I want to open a new file. We can get like os.exists. And this can probably just be format.t printf. Um, and this is going to be the stem dot. What are we calling this thing? Come on, QZL, and this is going to be the stem. Right. Do something like this. Otherwise we have to get maybe just if not exists that, then we uh, get a new file. Yeah. And if we have it, then we probably want to um, we do some stuff in machine the source machine. In the machine, we do an open. No, I guess we do that in Odin's. Where do we do like an open os.exists? os.read entire file. And this is going to be from file. Right, so if not okay, do return false, I guess. We couldn't read it. Um, Otherwise, we start getting into the stuff that I talked about like 10 years ago, it feels. So otherwise, we need to assert that data 0 to 4. Can we do something like so? We cannot. Can we do something like that? We don't have format. Can you do that? But we want like I want I want basic types. It's just a raw pointer plus len. Right, so we just do a transmute. Cool. Or raw data. I think I like the transmute better. You should just be a string, surely. Well, actually, can we raw data? got untyped string. Um, can we do something like says that to that? Right. Can we just huh? We can't just go equals between two slices. Can we uh we can do equal. I don't really like that, but uh, cool. Right, so we have got the first bite. So length is going to be U32. Where are we? We're at the header, which is here. Well, actually, we just get the U32. Can we like take 4 bytes and just treat it as a U32? I wonder if we can do that. Like, can I just do data? I kind of want to do index equal to 0. Maybe not index. Maybe like offset. Do something like that. Do something like that. And I feel like I'll probably get a helper method for that. Keep on pushing colors on my keyboard. We that one. Cool. What does the length have in store for us? We probably need something like that. Might do that. Uh, yeah, cool. So we can't do that. But we probably can get something. Um, can we get something with this? We can do a get U16. This looks alright. Um, we already have okay. This is one thing I don't really like. Core encoding. Core encoding session NDN. And I guess we should theoretically say that it is a big Indian, which we can do with dot big, something like that. Um, yeah, so here we already have a number. But then it will complain because length isn't declared. Can we do something like that, I wonder? No. Um, it's back to that one. Right, cool. That is looking good. Right, so what I want to do here, it's kind of some patterns are emerging. Because yeah, I kind of want to. I kind of want to read like a chunk at a time. Um, and I guess to do that would probably need like a what do we do here? We do something like private equal file. Yeah, I'm pretty sure that's it. With that, and I probably want to have like a struct of a we'll call it IFF because that is what it is. And this can be a chunk. Um, and read chunk, and this is going to take a proc. Well, it's really just going to take the data. Um, and it's going to just return an IFF chunk. Maybe and a boolean. Um, I wonder if I can do something like um, no, find that, and then a starting to get tight. Um, cool. So here, if we do this, we can have like a type, and this is going to be IFF type, and this can be our data, and it can just be a slice of U8. Um, and enum IFF type. This can be unknown to start with, then form, then IF header. We'll start with that. Cool. And then this, we can probably just do something like this, and just go Quetzal read chunk, and we can pass it just all of data, and this will return us a form, and we can assert form.type equals, and we can assert the type as that. And then we should have the well, I guess this could have a length. Yeah. And I guess here we can type can start with unknown. That should now just default to unknown. So we want to do a switch on. We want to do an assert that len of data is greater than equal to 8. And then we want to do a switch on data 0 to 4. Can we do such a switch? Wonder if that will do the trick. Boy, it didn't like that. How do we have enums? That's how we do things. do something like that. It's going back to. Yeah, cool. So we can't do that. But we could do something like this. Where did I see that get rolled out? It was in Slice. It was in here. I think I like this one better. Just something like that. Oh, yeah, you can't do that. Have to do something like this. Um, can't do that. So how will I go about this? I guess I can just do a switch on the first one, and if it is an F, looks ugly. I think I want something like this and do that and maybe do that and cool. So that should get the form. Cool. So that got the same. Um, so in this and then this offset, this is going to be 4. And just to keep it standard, so this is going to get the length. We're going to assert the len of data is greater than or equal to length plus 8. Make sure there's enough data, and then do chunk dot length equal length and chunk dot data equal data of 8 onwards, but only up to length. Do something like that. And we could probably even do a format but print. Well, actually, no, we can do like a debug v, and we can just get whatever thing it is. Doesn't have length. You can do that now. We can do that. Cool. So that got our length. I wonder if we change that to be that. Cool. Cool. So this didn't do what I wanted, but like a 4, then 3 zeros at the end. View. A 4, then 3 zeros at the end. Cool. So that read that entire form. So here we want to get the form.chunk, form.data, and here we have the opportunity, which it doesn't actually happen, but it could also have like other chunks. But form, from what I understand, so this needs a type ID. Needs a type ID. Which should hopefully have this. Do something like this. So this is always gonna have the length is in it. I'm gonna have a form type. And this form type is gonna have this IZS, and this is gonna have form type. So when we're reading a form, we want to really make sure it's got 12 bytes. Yeah. Cool. So I think I want to do, if not, and then do, come on, then do unreachable there. Because in the, call this a form, and this can be 4 up from there, 4 up from there. Really, this is 3 times 4. I'll just keep it 12. Right, so at 8, and I, what was it? IFZS, ZS, do form dot type, IFZS. Want to like, do something like that. Right, didn't like something there. We've missed a. We do Alright, runtime assertion. Cool. That was 51. Probably shouldn't. Yeah, I think I want to actually do that and maybe just get the. I don't know why. This is going to be -4 because we read from the type. Um, cool. So now we are trying to read chunks. So I guess we could add in some more types. We could, for example, read in valid chunk type. And we could probably give it a S there, and we could probably give it a give it something like that. Don't know why. Went back to that. Restore. Right, so if we go ifhd, and we can change our type to if. We don't have if hd. Do something like that. It's done that same thing. Cool, so now we are getting that other type. We still end at the right point. Our type is. Yeah, so this is the whole form packet, and then we get just the header, which is just these bytes here. So I guess we also need to get in the file data, like the actual ROM file, to compare things against it. But what I think, I have been spending a bit of time. Um, I think now is potentially a good time to. I wonder. Yeah, I wonder. I wonder a lot. Yeah. Anyhow, what I am thinking is, I might leave it there for the video. If we have a look at what we've done, we've added some things we should have also added this thing here. Yeah, that can just do that and uh, add startings of restore. Uh, and I think with that, I will leave it there for the video. I'm getting a bit tired and the output's not really coming out as I would like. So I'll leave it there and hopefully next time can get a bit more done on the old restoring. It's pretty mundane, like binary pathing, but it's interesting to kind of go and see, and it's interesting to kind of see the struggles as you go along. But yeah, anyway, thanks for watching, and until next time, I'll see you.